Hello everyone, this is Blender Guppy. Welcome to the Creative Flow 1.5 version 1.5 and Random Flow version 2.0 update video. So let's start with Creative Flow. There's not a lot of change except for the auto mirror having the 3D widget increase or decrease its size relative to the viewport distance. So you can see if I zoom out and in, you can see that the 3D widget size stays the same. Okay, so this is much better than the static version from before, since it can actually, depending on the origin and the size of the geometry, it can actually create a really small 3D widget for something so large, but some for the geometry that is so small. So it's kind of weird, and this is a much better version of it. Okay, so that's for Creative Flow. And we come to Random Flow. Also the same with the Auto Mirror. This is also available in the store as Fast Mirror, as a standalone operator, separate from Creative Flow and Random Flow. If you don't want the complicated add-ons and just want the simple effect of this operator, go ahead and get that. So uh, Random Flow, there's a lot of changes here. First off, UI changes. So auto smooth, auto mirror, extract faces, and apply mesh. It's no longer exposed outside and it's now inside the mesh submenu. So because of the increasing number of operators, I have to use the submenus in order to make the main menu shorter. It's now, because if I expose this, it's becoming too long. Okay. And we have in extras a bit of UI change as well. So cleanup is now above and separate from merge objects. Settings, we don't have the inset to V group anymore. It's now separated and is now a toggle for random loop extrude and random panels, and it's named use vertex group. So when I use this, use the cuts and create some patterns, and we have the use vertex group toggled on. Okay, I should increase the cuts some more. Okay, so if you select one of the vertices in the top faces, not the border ones, or the panel cut faces that creates the panel cut effects, so Shift G and vertex group, you can see that it only selected the top faces and not the panel cut faces or the border faces. So this is useful for material assignment. If you invert this, you will go to solid go to face selection mode using number 3. Okay, where's the hotkey? I forgot to set that. Okay, so that's number 3 for, so 1, I'll select a vert and Shift G to select similar vertex group. Go to face selection mode using number 3, and then you can use Control I to invert the selection, and now you have selected the border faces or the panel cut faces. This is useful for material assignment as well as UV attempts. Okay. So that is for the, this is also, it's also available in random loop extrude, vertex group. Oops. I didn't select the so it's just 12. And click on the use vertex group. Select a top vert and Shift G vertex group. Go to face selection, can invert, and just like that. So I think they're much better as a toggle for the operators that use them instead of being just a setting here. So you can change the value on the fly instead of undoing the operation and then toggling the settings on and off. Okay, so changes we have. So I've added in random loop extrude, and I've added the clear faces option. So you can use it here. So we have inner and we also have outer, which leaves only the top faces. So from before, it's only available in the random panels operator, in the clear faces here. And also from panel cutter, I have adapted the using inner and outer. I have adapted the floater toggle, which makes it looks like the resulting randomized result makes it looks like a part of the source mesh or the active mesh underneath by toggling off uh, the ray visibility except for the camera. So this trick only works in cycles, and this toggle is available for random panels and yeah, I guess random panel only. So it's not available here in um random loop extrude. Okay, so moving on, random axis. So I think is this a past version change or is it now change? I think this is a past version. No changes here. So random cells and a bit of a UI change. So thickness is now underneath. Is now here. So to make it clear that okay, use the cuts to make it more transparent that the thickness or this toggle here in cut method is affecting thickness, not offset. And offset is here and offset mode here. So it makes sense that the thickness is underneath the cut method since the modes affect the values that you set here. And we also have floater here that creates the same effect as the one with the random panels. Okay, so moving on. Random tubes. Wait. Random scatter. We have mirror, increase the resolution a bit. We have back to random cells. We have the use mirror toggle. It's not available in, oops. It's not available in random axis extrude and random panels and random loop extrude, but it's available for random cells, scatter, random tubes, random cables, panel screws, and I think quick displacement. So what it does is, let's see, random, so let use sharp, use only 12 and thickness 0 for the offset. Okay, number. So this is symmetrical and this is using the mirror modifier. So if you are going for an effect by using either thickness and offset or just offset by exploding this. So individual means randomized individual offset. Let's create a thickness. So the result is symmetrical because it's inheriting the mirror modifier. You can toggle this off. So it uses the entire source object or the active object as an applied mesh. without the mirror modifier, or with the mirror modifier applied. So the resulting random cells will be asymmetrical. Okay, so you can use this option if you're using the if you don't want symmetry. And this is all true for random scatter points maximum. Let's explode this. So you can see that this is symmetrical. You can toggle on not use toggle off use mirror to have the result have an asymmetrical result. Okay, and also some change in there's also a new toggle for random scatter, which is the uniform scale. So right now we have the main scale here, and we also have the secondary scale, which you can scale the resulting random scatter objects in the XYZ axis. But you can forego this too by using uniform scale and just do this. Okay, so they have uniform scale. This is useful for scattering low poly turrets on your spaceships or anything that you want on your spaceship. So you can use this by toggling off uniform scale. So the turrets, for example, if you use a mesh or a collection, those mesh or geometries will have different sizes because this is meant for randomization. But if you toggle this off, they will have a uniform scale. Okay, so random tubes, we have use mirror as well. So if it increase the cuts, okay, so that's a symmetry. So you can now use toggle this off, the use mirror, to have an asymmetrical result. So you don't have to apply the mesh, use the random tubes or the random operators for asymmetrical result, and then reapply the mirror. So you don't have to do that anymore for those operators. And we have random cables. So this is a bit tricky, and it depends on the symmetry axis. For example, if we have this, so this is selected, that means that on this side, these faces are also selected. So that means that when I have, for example, random tubes, oops. Okay, so use mirror. So this face are selected. So it means they are selected in this part, and this part as well. So that goes the same for the cables. If we toggle off use mirror, they will also come out in this area here and on that area there. So I think this is useful if we turn that off. So in that context, I think it is useful. And also another context, the the mirroring is not reflected on the top side, or in this case the z-axis. So they don't hang out in this part here and just there. So if I use mirror, you see that this set of faces or this area of faces have different results. So you can toggle this off. For more extreme results, you can just use the old way, which is extracting faces and then using the cables for that, or the other random operators to generate asymmetrical results. Okay, so that is for random cables, random flow, random animation, normal picker, panel screws. Okay, panel screws. Let's give the z-axis back. Oops, this part. So panel screws also has the use mirror toggle. When you use example, we use whoops captive, a margin, and increase the ranges. So we have the corner verts. So they are corner verts in reality because these are not real geometry. They are geometry that is provided by the mirror modifier. So they are virtual geometry. So we have the corner verts here, and we are using angle threshold. So depending on the angle of the vertices in the corner terminal edges, it will create uh, panel screws. So we have it here and here and here. But if you turn off use mirror, you only have this one here and here. So from before, you have to tag the vert here. So mesh data, tag verts, and then use panel screws. So for example, this one, let's turn on use mirror and use tag verts. So that's another way. But since we have this toggle, we can just use this to avoid all the tagged verts action. Okay, so panel cloth, and this is a lot. Holy crap, where do I start? Okay, and also quick displacement. This is like a whole new add-on that is built into an add-on. Okay, let's just I think just take it slow, make it faster. Okay, panel cloth, UI change. So let's flip the face. So the result will be here. Panel cloth, increase the subdivision, and noise seeds, source level, material index. We have shade smooth. Individual seed. Individual is now individual seed. Wow, which means that each separate each 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 separate island will have its own different randomization. So for example, here, panel cloth, seam, and then we toggle off individual seed and make a difference here. So they have a different result per random seed. Okay, so the functionality is still on the old version. It's just the name that has changed to make the toggle more transparent. Okay, so panel cloth, remove selected. Um, so from before, it only removes the selected faces if the selected faces are not the entire object. But right now, you can remove the object itself from the scene if you have selected all of its faces. Whoops. Oh, the brush. Okay, so remove selected. So you can see that the plane object here has disappeared, and also in the outliner. And now the selected object after the operation becomes the randomized result. And preserve corner pin. Oh, that's the new one. Object collections and a bit of UI change as well. So when you click this, a new toggle will be shown, which is the collide to source, which means that the randomized result will collide to the active object or the source object, and the active collisions will, of course, collide to the objects that are pre-selected before the active mesh. This one, oops. So selecting this one, and the object you're going to use for the cloth will be the last one and will be the active object when we use the panel cloth operator and increase the subdivision. You can see that it is colliding to the previously selected objects. So if you toggle this off, there's no collision. Toggling this on. And for the UI, collision, and then we have the quality. And I've removed the clamp because apparently doesn't do really anything that is substantially noticeable. So quality of the collision, object distance, and object thickness. Object thickness is from the resulting cloth, and its distance from the um colliding objects or collision objects. And object distance is from the collision objects and its distance from the cloth. Okay. And we have self collision, and self distance. I guess this is its distance from the elements in the mesh. Okay, when a vert collides on another point or a vert, this is your distance here. Okay, self collision. We have the pin. Okay, now let's go to the unpinning method. It's taking it slow that it works. Okay, the unpinning method. This is really cool. Okay, so if you use, we're using Mark Sharp for the pinning. So Mark Sim cuts the mesh. Mark Sharp pins the cloth. Mark Sim cuts the cloth or the mesh. Mark Sharp pins the cloth or the mesh faces or verts. Okay, so for example, Mark Sharp here, panel cloth, increase the subdivision. You can see that the cloth is being pinned on that edge, but if the Mark Sharp is on the boundary edges or the boundary selection for that matter. So for example here in the edges you use for the or the let me rephrase this. The border, the edges at the border of the selection. Let's delete this. Clear sharp. Yeah, that's right. It's not at the actual border edges, but at the border edges of the selection. If there's a mark sharp edge there, instead of pinning, it will release the cloth. It will actually unpin the cloth. Okay, so panel cloth, increase subdivision, and there you see the hanging effect. Okay, so you can also use this here, mark sharp, mark sharp, and panel cloth. Oh, this. Or use it on the entire border. Then And you can see that it's hanging on a vert right here on the sharp corner. And this is where the preserve corner pin comes in, and the angle. This is the angle of the vertices, the angle of the edges of the vert in the corner of the face selection, in the corner of the border, in the corner of the border of the face selection. So if you unhook this, so it releases the cloth, preserve corner pin. So you can create things like, if I remove this, they're sharp. So wait, okay, that's correct. So there are no more sharp edges here, so it's stuck to the edge, and we have um, the corner verts being pinned to the sharp corner of the of the face selection. If we release this, you essentially have a Superman cape. Okay, preserve corner pin, and you can create a variety of really cool effects with this. Let's see, subdivision. Don't use too much. 10 and 5, and increase the mass. 8. You can have something like that on and also you can create stuff like this with the corner pinning. So the ones that you saw in my video where I created the tent. Oops, Alt E, extrude edges. Well, extrude edges only. What? Alt E, extrude verts. Okay, and then separating this, going to extras in creative flow, edges to curve. Oh, okay. No selection. Edges to curve, create the depth. And this is just a fast basic example. Where is the, there we go. Okay, mark sharp the edges. Oh, that's too much. So 2 and 3, and then mass is 1. So with this, if you want to properly view the result, you can just use the remove selected faces, just like that. So mass, so you can create effects like that. It's really cool. So Mark sharp edges. We'll release them if the mark sharp edge is at the border of the selection. Mark sharp. And if we use this, I'll cloth, okay, restore the defaults, rotation scale. I think the normals will calculate outside. So we have that. But you can see that we want to release it also on the inside. So we will instead of just the mark sharp, you can also mark seam this. So mark seam splits the geometry, and it is the same. Once it is split, it is the same. That edge is the same as a border edge of a set of faces. So if we use this and use the split mode sim, you can see that it cut them, and we use the individual seed, and gravity is 1 to 5, 6. Mass is 1, and you have different result for each object. So bake frames, and then seed, and you have different result for each hanging objects because they are separate faces of islands. There you go. So pretty, really good, really cool trick. Just using the mark sharp and the mark seam combination. Okay, so that is for no face is selected. Final cut. Okay, so another use of remove selected when it comes to cylinder before we move on to quick displacement. It's gonna be explaining a whole operator. So yeah. So for this one, panel cloth. So remove selected. Now you can see the result of the operator with the faces removed. Just be careful because this is destructive. If you remove the faces, then in the resulting uh, geometry, the faces are also removed. Okay, so watch out for that. Now let's go for now let's go to uh before quick displacement. I have the utility operator, which is load images, and this is going to be used in tandem with quick displacement, much like um mesh. Tag verts is used for quad slice and some random operators here. So this utility operator works with quick displacement for when you select images instead of clouds for the displacement type. Okay, so you can use it to load images. So because apparently the image browser doesn't work with the redo panel. What works with the redo panel is a search bar for the images that are already in Blender, but not the images that are outside of Blender, so you can't load it up using the redo panel. So I have to make an external operator to do that to make it faster for you. You can do that manually by selecting image editor, then using this button here, but that's really who's got time to pick this small button here. Okay, so you can just use the operator. Quick load images. Go to your images. I'm going to load this up, preload this. You can select multiple and load images. So now they're in Blender image editor. You can see the 0 because they don't have any users yet. So these 0 assets will be removed from Blender once you quit the software. So they're part of they're going to be auto cleaned. They have no users. But don't worry, you can just load them up again using the load images operator. So quick displacement. So right now you can only use clouds and image for the displacement. I will add more in the future, but only the useful ones for the operator. Okay. And we have noise bases, which basically are the noise for the clouds available for the clouds. Noise bases that are available for the clouds. Cloud type displacement. We have the mode, which is if you want to displace all the faces or just the selection of faces. Coordinates, if what coordinates you want to use for the displacement type, so UV or object. And then we have the strength, the mid level that you can see this in the displacement modifier. This whole add-on is using multiple modifiers to create its effect, and we are using this single operator to basically speed up the entire process. We have the size and the size of the noise, the depth, the nabla. I didn't include the nabla because it's not doing anything when I change the uh, values. So it's out. So location with object is going to be different. The object's mapping will be here. We have the location, the rotation, and the scale. For UV, it is also different. We have the location, which you can randomize, the rotation, and the size will be the scale. Okay, so for object, it's different. You also have the size, but you also have this location, rotation, and scale, which you can change in the X, Y, and Z axis. And UV cuts. Okay, this is the when you use the operator for the first time, you need to increase this to see the effect because what the current faces that we have, which is 6, this will not be ideal for the displacement. Okay, noise. This noise comes with the subdivision. Noise seed. We have subsurf level, which is the same as panel cloth. It adds the subsurf modifier after and remains with the object. Object scale. So the scaling in this part is different from when you're using UV, an object. Basically, so the scaling is in terms of UV, affects the UV, and the object affects the empty that controls the displacement size. So this here, the object scale uh, an object rotation pertains to the source mesh or the active mesh you're using. Okay, so this, and not the element that you are using for displacement. So the above transformations are for the displacement texture or the type, and these transformations here are for the um, source object or the active object being used for the displacement. So for now, the process is destructive, and it will not be using live modifiers. So the resulting object will be an applied one. Okay. And for the future, I want to include a mode that will let you choose uh, a non-destructive version where the modifiers just pile up or kept, and you can just manually return to those modifier and change the values. Okay. But for now, this is destructive. In order for the selection mode to work, if I include the non-destructive method in the future, it will not work with selection. Okay, so this works non-destructive selection. The selection mode only works with the non-destructive method. Okay, size and strength. So let's include all the faces. So the ones that you see me create in the videos for Instagram and Twitter, I do them in stages. So we have smoothing here. So we have subdivision here that increases the subdivision of the mesh, increases the faces, and the smoothing here, actually when you have really sharp, um mostly works with just this smoothing comes with the subdivision BMS operation. So it's different from this one here. So the smoothing comes before the displacement. So it is, this one is smoothing the base mesh that you are subdividing with this one. And the smoothing is connected to the operation here, as well to the cuts operation here, as well as this one, as well as the fractal. So they're different. So with the smoothing, you can see that it basically just puffs the entire object. So it's the same as this one, but using Bmesh, that's a Python module in Blender, scripting stuff. So when you see you smooth this, you see when you smooth this, you see effects like that. So you can use this effect actually for some really cool results. You just want to puff up the geometry and get rid of some really sharp edges. But the way I use this operator is create a lower resolution first, and then just increase the detail. So for example, this cube, I'm going to just subdivide this just a few times in order for the smoothing to be really strong. So this is the base smooth and this is the smooth repeat. So if you increase the subdivision a lot, the effect of this will be, the effect of the smoothing will be less powerful. So if you really want to affect it, so zero subdivision, you can see that the cube is smooth to non-existence, almost to non-existence. So you can increase the size, the strength, basically wobble this up. Okay. And we can increase the the smoothness, and also increase this to buff it up. And then since we're using UV, you're gonna use object for object. It looks like that because for UV and object, they're going to have a different size. Basically for UV, you can adjust the size. You can adjust the location and the location of the UV, the X and Y location, and random seed them. So what are we using? This one. And for object mapping or coordinates, you can adjust the location of the empty. The empty is invisible in the operation because the script is instantaneous. It creates the empty, then deletes it after the operation. So you can use the location, the rotation to rotate the cloud uh, texture. When we have the scale, you can scale it in the z-axis, make it really small. And we have the scale of the object. You can random seed them. When you use the random seed one, it uses the original value. When you go past one, it will randomize the value. So for example, like this one, we just we go back to UV. How did it end up like that? 0.1, 0.1, 0.5, 0.5, or just one, I guess. Okay, size. Yeah, they have a different size. It all depends on the size of the look of the UV. So we'll use this, decrease the size, probably increase that, and then use the operation again. Probably restore operator defaults, strength of 0.1, something smaller, and increasing the subdivision. Oh, 0.2, I have to affect the size. 0.1, there we go. And we have to smooth the source object from its with its new form to get rid of this really sharp edges. Remember that this affects the source mesh before the um displacement. Okay, so the displacement are not being smooth, the base mesh is. So increase the okay. This, there we go. It's creating a sharp. Yeah, well, probably did something wrong in the first stage, but you get the idea. This one here. So I just used two stages to create this, and the second stage is a much higher resolution to create this detail. So you can create multiple stages, but you need to plan out the geometry or the I mean the resolution for each stage because this is already really high, and if you use it can go farther, but you can see that it's already slowing down. So you need to plan out this is now its resolution. You need to plan out your resolution very well. So let's repeat that, and let's repeat it using the cloud texture, and then we'll use the um, image texture. So when you get this, practice on a cube first, and the PDF guide is also very old, and I plan to release to replace that with videos for each operator, much like Creative Flow, but it will take some time. Okay. Okay. Repeat and increase this the strength. Increase the size. That really pops him up. 1.5. We also have contrast here if you want to use it, and contrast and brightness. The depth is the detail of the texture. Let's use a less distorted image version of the displacement. Okay, we can use that. And then uh, create another one. So this one will be smaller, 0.1, and increase the resolution and put in some minor smoothing for the base mesh and increase the resolution for the. You can choose other displacement noise bases. We can use the brightness to create this effect, or contrast to create this effect. Increase the resolution, and you have something like that. Okay, this is really good for. And by the way, just to clarify, this also works with multiple selection. Store, strength, and size, 0.1. Increase the subdivision. Okay, so yeah, that works for multiple selection. And let's use images. So images, really cool for stuff like J's placement texture. You can create random buildings, or used for far, or should have duplicated this at the object level. So for example, this is our base building. Let's equalize the. I think this works better with evenly sized faces. So let's put in some edge loops and select the face. Yeah, we can just use the all faces mode. Quick displacement. Um, Image. Okay, you restore operator defaults, clouds, image, and in the image, oh, did I image editor? Did they get cleaned or something? Oh, it's still here. Didn't show up. Oh, there we go. Hmm. Okay, increase the resolution. You can use the object, but for image textures, it's much better to image type displacement. It's much better if you just UV the object. After the displacement, the UV will be preserved, but it will have more resolution. Okay, so you can increase some more faces. You can actually just use this kind of resolution, lower resolution, and get these details here poking out, and use this for far away or mid-range renders. But for closer renders, you might want to use other methods or really increase the resolution subdivision. So strength, let's use 0.15 or zero point 0.1. So with image, you have the filter size, and this is kind of like a blur effect. If I use 50, so this is useful if you have really jagged jagged results on the resolution that you're using. You can use filter to bring the noise down. Okay, 10, and you can see that yeah, they have different result. They have the same format except that the geometry has different dimensions. So we can use this to random seed the location of each UV and create different results for each building. Let's try 60 subdivision. Okay, so you can use this for creating such buildings. You can even use this. You can even use what's this? Decimate afterwards. Just be sure to keep all the details that you see. So let's try it here and decrease the subdivision first, just to be sure. Okay, actually, let's just use something like 40 and random seed the result. So each building has its own identity. So the size of the um texture is here. So one, oh, two. So the details are getting smaller. Zero point 0.5. So it's getting bigger as you decrease the size. Okay, so now each building has its own unique identity. We can also change the coordinates, the image if you like. Use this one. I think this needs more resolution in order to look good, and also work with the strength. Not not every uh, image texture will work with higher resolution or higher strength. I mean, not resolution. This one here. So these are JS placement textures that I used to test and also used to create some effects with the random flow. But I'm going to show you the result of an image a seamless image I baked. I don't think it's seamless. It's an image I baked from geometries created using random flow. So load image. I think it is this AO test here. We can use this. These are pipes and stuff. I think. Okay, so you can see that this is definitely random flow result because of the pipes and the local things. So we're going to test this for displacement, even though I baked this as an AO. So if you don't have JS placement, you can just create a bunch of stuff using a plane. I think I have a video for that, so go search that, where I baked something like this on a plane and then use it for displacement or normals. Okay, so we're going to use that. AO. Where's you? It's not updating because load images. Oops, I already load because it's the current. This actually does not. This apparently does not touch the radio panel. Okay, I didn't load it. Load it and use it for displacement. AO test. Increase the resolution. Okay, so too much filter. 5 R2. There we go. So you can use the let's generate random seeds and increase the resolution to 60. So it can work. So if you don't have JS placement, you can just use random flow to generate this result. So this has pipes and all that effects. So if you want that, generating, I think I can, no, random seed for the size, probably not. 1.5. There we go. And decrease the strength to something like 0.08. Alright, filter size to 1. There we go. All it this needs is a proper texture to make it shine. And you can use it for your um, concept art project. Okay, so that is with quick displacement. I think we can also use the oops. Oh no, it just crashed. Let's open Blender. And then close this. Okay, so I used sometimes probably because I used it on the applied result. The operator is already applied. Okay, screencast. So that is the quick displacement. And this is the one I used to create the Oumuamua render. Also a bunch of asteroids in the asteroid body in the mining rig render. And you can use it to create a different uh, although you can use geonodes if uh, if you're looking for time and doesn't want to create a new node setup from the start, you can use this. But this also have different effects because of the other displacement type like the image. So I use this to also create extract faces from a spaceship. So using the extract faces operator, because the process is destructive. So I extract faces first from, say, a spaceship, then use displacement and use the image type to create really cool panel effects. So there are other stuff you can do with this, just because of the other utility operators in random flow, and not just use it for rocks. Okay, and then we have, okay, so that's quick displacement and that's load images, and then changes for the randomization. And this is more, I think, more apparent with random cells, and you see it in action here when I use random seed, especially in rotation. So for example, in rotation here, I think this also has, but yeah, random scatter and the random scatter object. So right now, if the rotation is 0 and you use random seed past 1, it will now randomize. So from before, you have to enter a value in order for the process to randomize. So the randomization, for example, is 25. The randomization will be from minus 25 degrees to positive 25 degrees. So if they are 0, it will use negative 360 degrees and randomize the values from that to positive 360 degrees. And scale 0. If it is 0, it will randomize from negative 1 to positive 1 value. So those are the changes. So you don't have to actually enter stuff on the rotation anymore. It works without that. The random seed works without that. And what else? Yeah, I think that's it. If I've forgotten something, just remind me in the comments section. Okay, so when you see this video or receive the email, go to the store you bought the add-on from, go to the product page, then download your free updates in there. Okay, so that's it for this video. If you have any questions, use the comment section or the links in the description. Thank you for watching and have a nice day.